Okay, dear students, last period we have studied first method to study this maxima and minima, that is the first derivatives test, and what is the local maxima, etc. Now today we will see second method to study this maxima and minima, that is second derivatives test. So here we are getting the perfect or correct maximum value, correct minimum value, and this method is widely used in application. So what is the second derivatives test? So for that, how we will proceed example? So we will write the procedure to solve the example. So first step, let y is equal to f of x be function of x. So that function is sometimes given, sometimes you have to prepare the example. Second step, you find first two derivative, find dy by dx, that is f dash x, and d2y by dx square, that is f double dash x. So you find first two derivatives in second step. Third step, you know this the tangent at maximum and minimum point is parallel to x-axis. So first derivative is dy by dx, that is f dash x is 0. So for both maxima and minima, dy by dx, that is f dash x equal to 0. Now you solve this equation. So solving equation 3, find values of x. Say x is equal to, suppose, a, b, c, etc. like this. So that you find the points of the curve at which the function is maximum or minimum. Now fifth, we'll use second derivative, that is by Lagrange's conditions. At x is equal to a. If f dash a less than 0, then f of a is maximum. If f dash a greater than 0, positive value is coming, then f of a is minimum. If f dash a equal to coming 0, then point x is equal to a is point of inflection. Or saddle point. Point of inflection or saddle point. And f of a is not maximum or minimum. Similarly, proceed for other points. What will be the points of the curve? For each point, you proceed this Lagrange's conditions. So we will get maximum values, minimum values, also we will get extreme points, stationary points, and so on. So this is the procedure of the second derivatives test to study maxima and minima. Now with the example, we will study how to solve the examples for this by the second derivatives test. So find maximum and minimum values of function, find maximum and minimum values of function f of x equal to suppose 2x cube minus 21x square plus 36x minus 20. So solution. So f of x, given function, equation already provided, 2x cube minus 21x square plus 36x minus 20. Now find first two derivatives. So f dash x is equal to 6x square minus 42x plus 36. F double dash x is equal to 12x minus 42. Now third step, for maxima and minima, f dash x is equal to 0. So f dash x equal to 0, that is 6x square minus 42x plus 36 is equal to, we get 0. Now solving this equation, you find the values of x, that is point on the curve. So 6 will take common outside, so x square minus 7x plus 6. So x square minus 7x plus 6 equal to 0. Now factorize this 6. So 6 will factorize as 6 into 1. Now here plus, here minus, both are minus. 6 minus 6 minus 1 is minus 7. Product is 6. So factors are x minus 1 and x minus 6 equal to 0. So therefore x is equal to 1 or x is equal to 6. So these are the points on the curve. Now apply by Lagrange's conditions. At x is equal to 1, f double dash 1 equal to 12 into 1 minus 42. So 12 minus 42, so that is equal to minus 30, less than 0. Less than 0 means maximum. Therefore, f of 1 is maximum. And f max is equal to f of 1, and that is equal to, now put in the equation of function x is equal to 1. So 2 into 1 cube minus 21 into 1 square plus 36 into 1 minus 20. So that is equal to 2 minus 21 plus 36 minus 20. So 38 minus 41. So minus 3. So maximum value of function is minus 3 at x is equal to 1. So x is equal to 1 is the stationary point or extreme point, and this value is extreme value. And at x is equal to 6, so if you put x is equal to 6 in second derivatives, f double dash 6 is equal to 12 into 6 minus 42. So this is coming 72 minus 42. 30, positive value greater than 0. Greater than 0 means minimum. Therefore, f of 6 is minimum and f minimum is equal to f of 6. So in the equation of function, we will put this value. So 2 into 6 2 minus 21, 6 square plus 36 into 6 minus 20. So that is equal to, so 6 to 216 so 432. minus, now 6 square 36 into 21. So 756 plus 36 into 6, 216 minus 20. So that is equal to 6 plus 2 is 8, 3, 4, 6 minus minus 128 less than 0. So therefore, F minimum, F minimum is equal to minus 128. F minimum is equal to F of 6, that is minus 128 at x is equal to 6. So like this we will find maximum and minimum values for the given function. Now sometimes instead of giving the equation of function, they are giving the theoretical example. So in that case, you want to prepare the function yourself and then you want to proceed the same way. We will take one example of that type. So suppose example, we'll check an example. A metal wire of 36 centimeter long is bent to form a rectangle. Find its dimensions when its area is maximum. So you have given the metal wire, suppose AB, of length is given 36 centimeter. Now it is bent and it is converted to the rectangle. So we'll consider, suppose X is the breadth, length, and y is equal to breadth of the rectangle. So let x is equal to length, y is equal to breadth of rectangle. Therefore, perimeter, so length is converted into perimeter. So perimeter 2x plus 2y is equal to, we get 36. So x plus y is equal to 18. So y is equal to, we get 18 minus x. So we are getting the relation between these two variables which are we have assumed. Now you want to study here the maxima and minima for area. So area of rectangle A equal to, so x square. So formula. So you must know the formula of area, surface area, value, etc. So here for an area it is only one variable is required. So put y value 18 minus x. So area is equal to 18x minus x square. Now next part is the same as the previous example. So find first two derivatives now. So dA upon dx is equal to 18 minus 2x. d2a by dx square minus 2. For maximum or minimum area, dA upon dx equal to 0. So 18 minus 2x is equal to 0. So x is equal to 9 centimeter. At x is equal to 9 centimeter, second derivative is d2a by dx square. So minus 2 constant less than 0. Less than 0 means maximum. Therefore, area is maximum. Now here, when x is equal to 9, y is equal to 18 minus 9 means 9 centimeter. So area is, therefore, area of rectangle is maximum when it is square of side 9 centimeter. So when the rectangle is the square of side 9 centimeter, we get area of that rectangle maximum. So in this way, you can solve the examples for maxima and minima from the textbook. Some examples you want to solve, you practice. So you will get the idea how we solve these examples of maxima. Okay, thank you.